Welcome everybody. I'm Julian Schindler from the German Aerospace Center, and today I take you through my preliminary results presentation of H2020 Trans 8. Automated driving is a great opportunity. It will offer more comfortable and relaxed traveling by respecting your individual needs. Especially higher levels of automation will give you a lot of freedom. But we should never forget that all vehicle automation functions will have their limitations. Especially in the first years or even decades, there will be circumstances on the road which cannot be handled by the systems. In these cases, the vehicle automation needs to give control back to an operator, most likely the driver. The driver will need to understand the current situation and take over control appropriately. If he doesn't, the system needs to stay in safe conditions, perform a so-called minimum risk maneuver, and therefore stop in most cases. The question is, how do these stops affect our traffic systems? Will automated driving at the end of the day result in even more traffic jams due to system limitations? This is where the Trans 8 project started. Being a medium-sized H2020 project, which started in September 2017 and is now about to end, 7 partners had the chance to look in detail into this topic. In the project, we were not only looking at single vehicles' transition of controls. If one vehicle is not able to cope with the situation, others may face the very same limitations. If there are several vehicles issuing a transition of control at the very same location, we call this a transition area. And those transition areas, several of the transitions will also fail. Minimum risk maneuvers will occur and therefore also stops on the road. The reason for the TOC can be various. The effects on the traffic system, nevertheless, may be quite similar. For completeness, Trans 8 is not only looking at effects when the driver takes over control, but also on effects after such situations where several vehicle automations are enabled again. But Trans 8 is not only looking at the effects of automated limitations of several vehicles, it is also about providing traffic management measures to avoid negative impacts. In the project, local infrastructure takes over the role of helping the vehicles to cope with the situations. As the infrastructure can be deployed, tailored to the situation, it can be equipped with special sensors needed to get a full overview or may have information about how vehicles should proceed driving in the area. To understand how and where vehicle automations fail and how traffic management measures can be of help, the project in the beginning performed several literature studies, expert interviews, and stakeholder workshops. As results, 3 categories of infrastructure services have been defined. First goal should be to prevent the transition of controls and minimum risk maneuvers on the road. We found 3 different ways of doing this: by providing path information, by providing speed, headway or lane advice, or by separating traffic. Second, if a transition of control or minimum risk maneuver is unavoidable, infrastructure may support the vehicles in finding the best way to stop. Besides, it has been found that a distribution of transition of controls and minimum risk maneuvers in time and space can benefit the situation. Each service is subdivided into a couple of use cases. This image gives you a rough overview. In the top row, there are the investigated use cases for the prevention of transition of controls by providing path information. In each of the use cases, the automated vehicle, shown in blue, can only overcome the given situation by breaking the law, either by driving on a bus lane or by using the emergency lane for queuing. In Service 2, the investigated use cases deal with cooperative lane changes and merging, as well as performing a right turn from the wrong lane. The last prevention service, Service 3, deals with traffic separation on highways to reduce dangerous lane changes. And Service 4, an automated vehicle not able to pass roadworks, is stopping in a safe spot instead of blocking the only free lane. Service 5 deals with the distribution of transition of controls and minimum risk maneuvers to avoid negative impacts of several transitions at the same spot. The service has also been investigated together with Service 5 as the availability of safe spots also requires different times for transition of controls. Each use case has been tested in several scenarios, first in simulation and then in real-world prototypes. But before, several enabling technologies had to be investigated. V2X messages have been designed always adhering current standards and developments of other projects. Cooperative sensing has been investigated, allowing a collective perception by infrastructure and vehicles. Cooperative maneuvering allows handling of situations like lane changes in a very smooth way. As the communication is rising, Trans 8 also investigated compression techniques and reliable communication. But since not all vehicles will be automated from one day to the next, also handling of conventional vehicles was in focus, either by designing external lights showing automation issues or by infrastructure support via variable message signs. During the project, several simulations have been performed. They revealed that transitions of control will have large negative impact when the penetration rate of automated vehicles rises. On the other hand, traffic management measures like those developed in the project will severely improve traffic efficiency again, leading to a higher average flow and speed. Also, safety and emissions will be improved by such measures. Here, you can see the results of simple transitions of control without and with traffic management measures. In this case, the distribution of takeover requests along the road is in focus. Without traffic management, congestions will be unavoidable. Looking closer at some results with more complex simulations, including communication simulations, nevertheless reveals that simulations have to be performed with care. Just simulating vehicle movements and traffic management measures may be simpler and faster, but including a detailed communication simulation will give you much more insights into real improvements. Here you can see in the very same scenario that communication errors will slightly reduce the positive impact of transition distribution, especially when more vehicles are on the road. But still, the effect is remarkable compared to the shown results on the last page. Trans 8 did not stop the developments in simulation. We wanted to know if the measures also work in real world. That's why we started several field trials where we successfully investigated the performance of infrastructure components like cameras, of communication protocols, and of vehicle automations adhering to the given infrastructure advice. On the right hand, you can see an example of a scenario showcased on a test track and dealing with safe stopping positions of automated vehicles in case of occurring minimum risk maneuvers. On the left, you can see a cooperative merging assist showcased on a highway near Amsterdam and public traffic. As the project is currently coming to its end, we are now taking the necessary steps to bring the results to the market. We had stakeholder consultation meetings before and during the pandemic to prepare this important step. In those, it has been found that the clear definition of operational design domains of automated vehicles, and even more important for transition areas, the exchange of this information with infrastructure and traffic management operators are required. Same goes to the definition of infrastructure capabilities, as for example done with the ISAT levels in the sister project Inframix. A roadmap and further guidelines for stakeholders will be released at the end of the project. Transition areas may be a futuristic topic, but action is required now to allow a smooth introduction of automated vehicles.